Need air density for that exhaust calculation you're working on soon? Stay tuned for our next quick tip.
Welcome to a new edition of the Engineering Quick Tips.
Welcome back. This is Dave, your quick tip guide for the engineering job link. Today I wanted to talk about air, the ideal gas law. So I'll just start with Avogadro's law. Avogadro's law states, or is stated as the equation of state for ideal gases. An equation of state is a relationship that predicts the gas state from a set of two other independent properties. All right. Now the properties we're talking about today are in the ideal gas equation. PV equals MRT. P is for pressure, V volume, M mass, R is the universal gas constant, and T is temperature. Now temperatures that are used in the ideal gas equation are going to be on an absolute scale. So in here we'll be using Kelvin or Rankine. All right. So if you rearrange that equation, what you end up with, if you're trying to get mass over volume, which is density, you get P over RT is equal to the density. All right. That's what that little symbol rho is for. Rho equals P over RT. All right. Now, if we think of this gas in two different states, at one temperature and at another temperature, we'll have a density associated with that state 1 and state 2. So if we know the density at state 1, we are looking for the density at state 2. All right. So if you take a ratio of the density of 1 over the density of 2, you take that equation that we already derived and also divide those two as well, because it's a linear relationship. All right. Now if you do that and you hold pressure constant in an ideal state, R is also constant. So what you have is terms in this equation that cancel out. All right, and then after they cancel out and you rearrange that equation for your state 2 density, you end up with rho 2 equals the density known times the known temperature over the new temperature, the target temperature that you are after. Okay? So this is the equation that is set up in my spreadsheet. Okay? So here's the spreadsheet, little simple spreadsheet, nothing to it. I have an initial state where the temperature is known at 32 degrees Fahrenheit as 273 degrees Kelvin, and the density of air at that temperature is 0.08069 pounds per cubic foot. Now knowing this, we can get a density at any other temperature. So all you do is enter the temperature at the yellow cell, and you can get another density. Say at 700 degrees Fahrenheit, your air density is 0.03421 pounds per cubic foot. Okay. Now further to the left here, we have metric conversions, and that's just the same density in metric. Now if you also wanted to make a table and see your density distribution across a temperature range, you can do that at the bottom of this spreadsheet. You enter an increment and enter a starting temperature. Here I've got 100 degrees start, and every 50 degrees it plots a data point and puts that over to the right side of the spreadsheet here on this graph. So you've got a little distribution there to look at if you wanted that for some presentation maybe. Okay, now all this is for air. This is the air density tab. If you go to the other gases tab, there's a few other gases in here. Now this is got an added feature on it as temperature and a pressure. Now say for air at 70 degrees Fahrenheit and 0 psig, your density is going to be 0.0749 pounds per cubic foot, where you hold pressure constant. Now I have another column on here where you hold temperature constant, and you're looking at different pressures. Say you wanted that same point at a higher pressure, say 50 psig. That'll change your density on the far column here as well. So you have that for air, acetylene, and there's ammonia and several other gases on here. And there you have it. There's a quick and dirty spreadsheet for density calculation using the IdealGas equation, and you can use that for other gases as well. And that is basically it. Not a whole lot to it. So that completes our quick tip for today. Be sure to take a look at the notes, and I'll give you this spreadsheet for free, and you can manipulate it as you needed. If you want to share it, please share the link to my website so others can download it directly from there as well. Appreciate your time. This video was brought to you by the Engineering Job Link, where you can earn a dime from your spare time.